Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video introduces combinations and shows how they can be used to calculate probability. Let's get started. So, remember in the previous mini lecture, we talked about permutations. We said that the order of the elements matters. Well, if the order of the elements doesn't matter, then what we're calculating are combinations and not permutations. You can see the formula for calculating combinations here at the bottom of the screen. And if you look at this equation right here, you'll notice that it looks amazingly similar to the one we were using to calculate permutations, except for one little guy right here, and that's this guy. The r factorial that's tacked here on the end of your denominator. So this is the thing that makes combinations different from the permutations. And it's because of this little guy right here that you're going to be dividing, in both cases, between permutations and combinations. You're going to have the same numerator on top, but the number on the bottom is going to be larger for combinations because you're multiplying here by r factorial. So the number of combinations that you get for the same problem will always be less than the number of permutations that you calculate. So it really makes a difference whether or not you use the combinations or the permutations. And so that's why the first question we ask is, does the order matter? If the order matters, then you're going to use permutations. If the order doesn't matter, then you're going to use combinations. Let's look at an example problem to illustrate. So here we have the Pennsylvania Lottery, and out there in PA, they've got this game called Match 6. So when you play Match 6, you win the jackpot by selecting 6 different numbers from 1 to 49, and if the 6 that you select are the same as the ones that are selected by the lottery, then you win. And it doesn't matter what the order is for the numbers, okay? You just have to have the same 6 numbers. So, what is the probability of winning the jackpot playing Match 6 if you purchase just one ticket? Okay, we can do this. Probabilities, the part over the whole. So, first thing we're going to ask ourselves to calculate the whole is, does the order matter? And here, the order does not matter because it says the numbers can be drawn in any order. So that means we're going to calculate combinations to get our total sample space, the whole part for our probability calculation, because the order doesn't matter. So here's our formula for calculating combinations. We plug in what we know. There's 49 numbers we can choose from, and we're choosing 6 of them. So n is going to be 49, and r is going to be 6. So 49 minus the 6 gives us 43. So we've got 49 factorial over 43 factorial times 6 factorial. And when we punch that out on our calculator, out comes 13,983,816. This is the size of our sample space. So now that we've got the whole, we can calculate the probability. Just put the part over the whole. 1 is our part because we're purchasing just one ticket. And then the whole is the sample space that we just calculated with our combination equation. So 1 over 13,983,816 is a very small number. If you were to actually divide that through with your calculator, here's the number that you'd get. As you can see, this is a really, really small number. The odds are really stacked against you when you're playing the lottery. And in fact, no matter what lottery game you're playing, the odds are going to be pretty similar to what you're seeing here. So the fact that anyone wins the lottery at all is a huge deal because the odds of winning, look at the probability. It's practically 0. Now, how many tickets would you have to purchase in order to get a reasonable chance of winning? Well, if we purchase 10 tickets, we can move this decimal place over 1 place. If we purchase 100 tickets, we can move it over 2 places and so forth. So how many places do we have to move this over? Well, we move it over 1, 2, 3, 4, 5, 6, 7, 8 places gives us a 7% chance. That's still kind of small. Let's move it over one more place, and now we've got 71%. That's a reasonable chance of winning the lottery. Well, how many tickets do we have to purchase to get that 71% chance of winning? If I purchase 10 tickets, I can move the decimal place over one place. 100 tickets, let's me move it over 2, 1,000, 10,000, 100,000, 1 million, 10 million, 100 million, 1 billion. I would have to purchase 1 billion tickets to have a reasonable chance of winning at the lottery, at least with this game. So I hope you can see that playing the lottery is a scam. Here's the math that proves it. You have to purchase a huge number of tickets. Nobody's going to go out and purchase 1 billion tickets to play any lottery game. And yet that's what you have to have a reasonable chance of winning. So the fact that anyone wins at all is a huge deal. And of course, the lottery plays that up because they want to give people the perception that this is something that's reasonably able to be accomplished. But when you do the math, you see the lottery is nothing but a scam. And all of the games that the lottery plays with people, like when you support the lottery, you're supporting education. Well, let me tell you something. The math here is pretty straightforward. So if you want to support education, here's what you do. Go find a teacher and give your money directly to the teacher. Okay? That's the best way that you could support education, in my opinion. I wouldn't give it to the lottery. Here the math is showing you the lottery is nothing but a scam. You're just throwing your money away with the lottery. So that's why we use combinations to calculate probability. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.